Next problem. If four straight lines ax plus by plus p equal to 0, ax plus by plus q equal to 0, cx plus dy plus r equal to 0 and cx plus dy plus s equal to 0 form a parallelogram, show that the area of the parallelogram so formed is modulus p minus q into r minus s by bc minus ed. Given lines ax plus by plus p equal to 0, take it as equation number 1. Then second equation ax plus by plus q equal to 0. Third equation cx plus dy plus r equal to 0. And fourth equation cx plus dy plus s equal to 0. Let ABCD be the given parallelogram, right? So this is the given parallelogram, such that line 1 represent the side AB, 2 represent the side CD, because parallel lines. So ax plus by for the both the line are same, right? Only constant term differ. Next, line 3 represent the side BC, and last one 4 represent the side DA. We know that the area of the parallelogram, which is equal to height into base, that is equation number 5. Let EF be the height h1 of the parallelogram. So we are taking the vertical height, so let it be EF, so that is h1, right? Then to find the height h1 of the parallelogram, so clearly the height EF, which is equal to distance between the side BC and DA, right? Opposite side, in between the opposite sides AD and BC, or BC and DA, the height is h1, right? That is the distance, perpendicular line between AD and BC, equal to distance between the parallel lines, right? 3 and 4. So we know distance between the parallel line. So there are two lines, suppose ax plus by in capital letter, right? To avoid the confusion, I am taking that capital letter side. Plus c1 equal to 0, ax plus by plus c2 equal to 0. Then distance is c1 minus c2 by root of a square plus b square. That is capital 1. Here a is equal to capital A is equal to c, capital B is equal to d, c1 equal to r, c2 equal to s. So 6 implies the height h1, that is EF, the distance, which is equal to r minus s by root of c square plus d square. That is equation number 7. Next, let GH be the height h2 of the parallelogram. So we are taking the horizontal height, right? Horizontal distance, that is also height, right? So this is ABCD given parallelogram. This is EF, vertical height h1. Then this is the GH, the horizontal distance, that is h2. So to find the height h2 of the parallelogram GH, so that is nothing but the distance between the line AB and CD. So opposite sides, there are parallel sides, right? So the lines are parallel. So that is equation number 8. So here A is equal to A, B is equal to B. That is capital A is equal to small a, capital B is equal to small b, C1 equal to P, C2 equal to Q. So using the distance between parallel line formula, so the height h2, that is GH, is equal to modulus P minus Q by root of a square plus b square, that is 9, right? Let theta be the angle between two adjacent sides, right? So AB and BC, so this is theta. To find angle theta, clearly theta is the angle between the line 1 and 3, right? Side means that is that represent the line, right? So that is line 1 and 3. So angle between line 1 and 3. So slope of 1 is, we know m1 equal to minus a by b, and slope of 3 m2, let it be m2, which is equal to minus c by d, right? Ax plus by plus c equal to 0, if it is the line, then slope of that line minus a by b. So that is, we are using that formula. For this line 1, we are taking slope is m1, that is equal to minus a by b. For the line 3, slope is m2, that is equal to minus c by d. We know angle between two lines is tan theta formula, which is equal to modulus m1 minus m2 by 1 plus m1 m2. So substituting the value, tan theta is equal to minus a by b minus c by d by 1 plus minus a by b into minus c by d, that is equal to c by d minus a by b by 1 plus ac by bd, right? Some in numerator minus ab minus into minus plus c by d, so I am writing c by d minus a by b. In the denominator, minus into minus plus, you will get 1 plus ac by bd. Taking LCM in the numerator, so bd is the LCM, so cross multiplying bc minus ad by bd. The denominator bd is LCM, so cross multiplying ac plus bd by bd. bd and bd get cancelled, right? So tan theta is equal to modulus bc minus ad by ac plus bd. Since tan theta we know opposite by adjacent, here we take opposite is equal to, just take as it is bc minus ad, and adjacent is ac plus bd, right? This is theta, opposite, adjacent, hypotenuse. This is bc minus ad, this is ac plus bd. So hypotenuse is equal to square root of opposite square plus adjacent square. So bc minus ad and ac plus bd the whole square. So using a plus b, a minus b formula and expanding, right? So minus 2abcd plus 2abcd get cancelled. So we are writing remaining terms, b square c square root of p square c square plus a square d square plus a square c square plus b square d square. We are grouping b square c square plus a square c square, marked in red and marked as it is in black. So c square is common, take it outside from these two, so a square plus b square into c square. So remaining term d square is common, take it outside, plus a square plus b square into d square. So from these two, a square plus b square is common, take it outside, so hypotenuse is equal to root of a square plus b square into c square plus d square. We know sin theta is equal to formula opposite by hypotenuse. Opposite is bc minus ad, hypotenuse is root of a square plus b square into c square plus d square. That is equation number 10. So to find the base bc, this is abcd, right? gh, so this is theta, right? So draw cr parallel to gh, right? From c you are making a line, right, perpendicular line to AB, which is equal to GH, that is the distance, right? So CR is equal to GH. From the right angle triangle BCR, sin theta is equal to opposite by hypotenuse, so that is CR by BC. CR is nothing but GH by BC. So sin theta is equal to GH by BC. So BC equal to, right, GH by sin theta. So from 9 and 10, so BC is equal to GH, right, modulus P minus Q by root of A square plus B square, we know, right? And sin theta value is BC minus AD by root of A square plus B square into C square plus D square, right? So you can write it as its reciprocal, the second term, right? P minus Q by root of A square B square into that reciprocal of the term root of A square plus B square into root of C square plus D square. We are splitting into two terms inside the square root, right? Because inside the square root you are having A square plus B square into C square plus D square. So we are separating root of A square plus B square first term into root of C square plus D square second term, whole divided by BC minus AD. So root of A square plus B square in the numerator and denominator get cancelled. So BC is equal to P minus Q into root of C square plus D square by BC minus AD. That is the base level, right? So to find the area of the parallelogram ABCD, so we know base into height is the area, that is BC into EF. So BC we know P from 11, P minus Q root of C square plus D square by BC minus AD. And EF also we know R minus S by root of C square plus D square from 7. So root of C square plus D square in the numerator and root of C square plus D square in the denominator get cancelled. So remaining term area of the triangle ABCD is equal to P minus Q into R minus S by BC minus AD. So it should be a positive area, so it should be inside the modulus value, modulus P minus Q into R minus S by BC minus AD. Thanks.